Good morning, grade 6s, and welcome to WorksheetCloud, grade 6 Natural Sciences. For those of you who've been here before, you know what to do. For those of you that haven't been here before and it's your first time here, let's get started. My name is Mrs. Hall, and I'm here to teach you about grade 6 Natural Science. So today's lesson is on the introduction to electricity. But before we get started, today is Friday, my favorite day of the week, as I'm sure it's yours as well. But remember, Monday is a public holiday. Yes, it's Freedom Day. So grade 6s, if you wake up on Monday morning and you're a little bit bored, I suggest you watch this video again. The concepts I'm teaching you today are quite intensive in that they are all new concepts. And in order to understand electricity going forward, I suggest you constantly go back and revise and consolidate your knowledge. So for those of you who wake up on Monday bored, please feel free to watch this video again. Because in the next few days, I will be delving deeper into electricity and what is expected of you at a grade 6 level. Let's get started. So today's objectives is to look at electricity in nature. We're going to look at the building blocks of atoms. We're going to look at electrostatic force. We're going to look at making charges flow, as well as conductors and insulators. So let's start with electricity in nature. So, electricity is all around us, as you know. It's powering technology like our cell phones, our computers, our lights, and even our air conditioners in this very warm climate that we live in. It's tough to escape it in our modern world. Even when you try to escape electricity, it's still at work throughout nature. From the lightning in a thunderstorm to the synapses inside our bodies. But what exactly is electricity, grade 6s? This is a very complicated question. And as you ask more questions, there really is not a definite answer, only abstract representations of how electricity interacts with our surroundings. So let's take a closer look. As you know, electricity is a natural phenomenon that occurs throughout nature and takes many different forms. Today, we are going to focus on current electricity, the stuff that powers our electronic gadgets. Yes, how would we survive without them, especially during this lockdown? Our goal is to understand how electricity flows from a power source through wires, lighting up LEDs, spinning the motors, and powering our communication devices that we all love to hate. So, electricity is briefly defined as the flow of electric charge. But there's so much more behind that simple statement. Where do the charges come from? And how do we move these charges if you look at them over here? Where do they move to? How does an electric charge cause mechanical motion in a motor or make things light up, like over here in this simple circuit diagram? To begin to explain what electricity is, we need to zoom way in beyond the matter and the molecules to the atoms that make up everything we interact with in life. So let's start with the building blocks of atoms. An atom is built with a combination of three distinct particles. We have electrons over here surrounding the outside of the atom. Okay, we have protons and neutrons, which are found in the nucleus or the middle of the atom. And they are densely packed together, the protons and the neutrons. And then there are surrounding electrons, like I said earlier. They orbit the nucleus of the atom. So the electrons in the atom are where electricity gets its name. In some elements, now elements are atoms in their purest form, and you need to remember that for going into grade 6, especially when we start looking at the periodic table. These elements, in the atoms in their purest form, there are electrons on the outside of the atom that when a force is applied, they can come loose and move to another atom. When a bunch of atoms are together and electrons are moving from one atom to the other in the same direction, this is called electricity. So here we have two atoms, okay? And as the outside electrons move from one atom to the other, that is the flow of electricity as the electrons are transferred. So electricity is the flow of electrons. Electricity, electrons. Electrons are critical to the workings of electricity. Like I said earlier, the common name, electrons, electricity. In its most stable, balanced state, an atom will have the same number of electrons as protons. So here we have the electrons on the outside of the atom, and in the nucleus we have the protons and the neutrons. And generally, the amount of electrons equals the amount of protons. They have the same number. As in the Bohr atom model, a nucleus with 29 protons, and in this case it's making it a copper atom, is surrounded by an equal number of electrons. So electricity is created as electrons flow from atom to atom. The atom's electrons aren't all forever bound to the atom. The electrons on the outer orbit of the atom are called valence electrons. It's a new term for you. You haven't heard them yet. They are the outer electrons. They are called valence electrons. With enough outside force, the valence electron can escape orbit of the atom and become free. Free electrons allow us to move charge, which is what electricity is all about. So charge is a property of matter. Just like we have the property of mass, volume, or density, which you've been learning about already, it is measurable. Just as you can quantify how much mass something has, you can also measure how much charge it has. The key concept with charge is that it can come in two types, a positive charge or a negative charge. Positive charge is your protons, your negative charge is your electrons. So let's take a closer look at this atom. In order to move charge, we need charge carriers, and that's where our knowledge of atomic particles, especially electrons and protons, come in handy. Again, just to recap, because this is all new to you and it's a lot to take in. On the outside of our atom, we have the electrons, and in the nucleus of our atom, we have the protons and the neutrons. Electrons always carry a negative charge, while protons always carry a positive charge. Neutrons, true to their name, are neutral, so they have no charge. Both electrons and protons carry the same amount of charge, just a different type. So, like I like to tell my grade 6s when I'm teaching them this section, a good way to remember is look at P. Okay, P is for protons, which are positive. P, protons, P, positive. E is for electrons, E, negative. And always think of the E there for negative. Okay, that's how you remember electrons are negative. And N for neutrons is easy. N, neutrons, N, neutral. Just a little simple way to remember. Electrostatic force. Electrostatic force, also called Coulomb's law, is a force that operates between charges. It states that charges of the same type repel each other, while charges of opposite types are attracted together. So we say that opposites attract, so opposite charges will attract, and likes repel. So here we have a positive charge and a negative charge, and they are attracted to each other. Here we have a positive charge and a positive charge, and they repel each other. The same with a negative charge and a negative charge, they repel each other. So here we have straightforward attraction field lines. A positive and a negative are attracted to each other, and positive and a positive repel each other. We call them repulsion field lines. So if this was a negative and a negative, it would also repel. The amount of force acting on two charges depends on how far they are from each other. The closer two charges get, the greater the force, either pushing together or pulling away. Thanks to electrostatic force, electrons will push away other electrons and only be attracted to the protons. This force is a part of the glue that holds the atoms together, but it's also the tool we need to make electrons and charges flow. So how do we make the charges flow? We now have all the tools to make charges flow. Electrons in atoms can act as our charge carrier because every electron carries a negative charge. If we free an electron from an atom and we force it to move, we can create electricity. Right, just remember the outside electrons on the outside of the atom are called valence electrons. So this is a copper atom diagram. It contains 29 protons in the nucleus, surrounded by bands of circling electrons. Electrons closer to the nucleus are hard to remove, while the valence, that's the outer ring of electrons, require very little energy to be ejected from this atom. So using enough electrostatic force on the valence electron, the outside circle of the atom, either pushing it with another negative charge or attracting it with a positive charge, we can eject the electron from orbit around the atom, creating a free electron. Now consider a copper wire. Okay, so a copper wire is just matter. Okay, everything is made up of matter, and this matter is filled with countless copper atoms. As our free electron is floating in a space between atoms, it's pulled and it's prodded by surrounding charges in that space. In this chaos, the free electrons find a new atom to latch onto, and in doing so, the negative charge of that electron ejects another valence electron from the atom. Now a new electron is drifting through space looking to do the same thing. The chain effect can continue on and on to create a flow of electrons called electric current. And here we have a very simplified model of charges flowing through different atoms to make current. And remember, the electrons on the outside are the valence electrons, and they can easily be ejected from the atom. Let's take a brief look at conductors and insulators. So, what is conductivity? It's when some elemental types of atoms are better than others at releasing their electrons. To get the best possible electron flow, we want to use atoms which don't hold very tightly to their valence electrons. An element's conductivity measures how tightly bound an electron is to an atom. So, elements with high conductivity, which has very mobile Mobile electrons are called conductors. These are the types of materials we want to use to make wires and other components which aid in electron flow. So metals like copper, which is a very good conductor of electricity, silver as well as gold are also usually our top choices for good conductors. While elements with very low conductivity are called insulators. Insulators serve a very important purpose. They prevent the flow of electrons. Popular insulators include glass, rubber, plastic, and air. So here we have a conductor again, any material that allows electric current to pass through it, any kind of metal, okay? Whereas an insulator is any material that does not allow electric current to pass through it, like the protective coating on wires. And we're going to look at that in a lot more detail as we go through this topic on electricity. So things like wood and cloth and rubber and glass, they don't allow electrons to flow through them. And there's a very good reason for that. Now, grade 6s, it's Friday. And because it's Friday, I'm going to end this lesson with a little video for you, just to cement everything I've taught you. Just remember, it's a lot to take in a very short period of time. So please watch the videos again. They're there, they're free, and hopefully they help you to cement your knowledge. Right, enjoy the video, and grade 6s, I will see you on Tuesday, not on Monday. Let's watch this video.
How electrons become electricity. Electrons are negatively charged particles in atoms. Electricity is the flow of electrons, and a force is needed to move electrons. First, we need to look at forces. Forces either push objects apart or pull them together. Gravity is a force of attraction that pulls objects together. Imagine sitting on a bench. The gravitational force attracts you to the earth and the earth to you, but the bench stops you from being pulled to the ground. But if a boulder falls on the bench, causing it to tip over, the force of attraction due to gravity pulls you to the ground. Where do electrons fit in? Electrons move as a result of a different force called the electromagnetic force. This force both attracts particles with opposite electric charges together, as well as repels particles with the same electric charge apart. Electricity in your house usually comes through copper wires which are connected to a power station. These wires form closed circuits which carry electricity. Before a switch is turned on, a circuit is not complete, and the free electrons in the copper are moving around randomly. After the switch is turned on, the open circuit closes. The difference in electrical charge at either end of the power station causes electrons to move in the same direction. Like charges repel, opposite charges attract. The flow of electrons is electricity. Check out our other videos about electricity, fuel, and heat.
So, grade 6s, there are homework sheets for you with memos. Just remember, this is only the introduction to electricity. So if you can't answer all the questions on worksheet 1, don't stress. Just wait for my second lesson on electricity, and then it will be that much more clearer to you. Have a great weekend. Enjoy. I hope you get to relax and take some time out and spend quality time with your families like you have been doing. Thanks for listening, grade 6s.